All right, here's your homework. First part will be easier than the second part. We'll do all of it together. So, what is the power term? So it's 3x to the fifth, which means it's positive with an odd exponent. So what direction does it go if it's positive with an odd exponent? If you have to go back to this page here in your notes, right, that describes it, 2 pages back, then you look at it until you remember it. Copying me is not the best. So we're trying it. So as x approaches infinity, the function goes up. The left end, as x goes to negative infinity, the left end goes down. Here, our power term, you can tell, I'm just going to write it right away, it's negative and even. So what does that mean? That means the right end, we know how to write that, goes down. That means the left end goes down. Number 3, again, you're not just copying me. I can tell it's negative with an odd exponent. The right end goes down, and the left end goes up. So we know if it has an even exponent, both ends go in the same direction. If it has an odd exponent, they go in opposite directions. If the power term is positive, the right end goes up. If the power term is negative, the right end goes down, and you can follow it from there. All right. Fraction has no effect. It's positive with an odd exponent, so the right end goes up. The left end goes down. Here we have positive with an even exponent. So that means the right end goes up and the left end goes up. So both ends go up. Last one, negative and even. How do I write that? So as x approaches infinity, the function that goes down. As x goes to negative infinity, the function also goes down. So the right end goes down, the left end goes down. Yay. Now, how do I understand this? So first of all, the power term is going to be negative and even. You understand why it's negative, and they both go in the same direction. And then how do you write down the end behavior with that? So both ends go down, and you learn how to write that properly. If I look here, the right end is up, which means it's positive, and they go in opposite directions, so it's odd. And then I write the end behavior. So again, the right end is up and the left end is down. Next, look at the ends. Both ends are up. So that means it's positive. Both are going the same direction, so it's even. And then we write the end behavior statement. So the right end goes up and the left end goes down. No, goes up. Both go up. Up, up, up. All right, next is working with Desmos. So can we type this in and be able to classify it and analyze it from Desmos? So I am going to do that. So let me type it in. I'm just on another screen here typing it in. You should type it in. So x cubed plus 9x squared plus 24x plus 21. Okay. So let me move this over. So I want to make sure I see all the see all the turning points. So beautiful turning points again. I love that. So this is a cubic because the degree is 3. Our minimum is at -2, 1. That's beautiful. 2 to the left, 1 up. I'm going to put it on my graph right away. The maximum is at -4 and 5. I'm going to put that on my graph right away. And then that's all I needed over here. And then I'm going to connect it nice and smooth and continuous. And in terms of it, there's my graph. I already know the end behavior. I know the right end goes up and the left end approaches. So x approaches infinity, the right end goes up. This says the left end goes down. All right, intervals. This first starts going up, so it increases. The start is negative infinity, and it increases until -4. Then it falls down, so from -4 to -2, and then from -2 to infinity, that's where it ends. It goes up. It goes up, then down, then up. Like a roller coaster. Up, and then the roller coaster goes down, then the roller coaster goes up. All right, number 11. Let's just classify it right away before I type it. This is a quartic, and the end behavior. What do you notice about the end behavior? The right end goes down, and the left end goes down as well. Both ends go down. You knew that. Then I'm going to type this in, and then I'll switch it over. So again, see how quick I should have just kept the other equation up. But it's going to take a minute to type this in. You should be practicing with me on Desmos. Alright, so I typed it in, and then I look at my turning points, and I'm going to write them down. So we have a minimum at negative, like -1 and -3. Let's get around. -1, -3. We have a maximum at -2, 2-ish. And then we have another maximum at like 0.3 and -0.4, something like that. So I'm going to put them on my graph away. So -1, -3, -2, 2, and then 0.3, and so just a little below. And then I'm going to connect and make my graph and finish it. So both ends go down, connect through the turning points. This increases to begin with up to up here point, what is this one? -2. And then it goes down, so that's -2 to like -1. Then it goes up. That's -1 to 0.3, and then the last part goes down. That's 0.3 to infinity. All right, 2 left for your homework. Again, what do I know? This is called quartic. The end behavior, we know the right end and left end go up. All right, what else do we know? I need to type this into Desmos. Let me do that. X to the 4th, subtract 3x squared plus 3x plus 1. All right, let's move this over. Make sure I see everything I need to. There's a tricky part here. So, I don't know, we'll focus in here. So we have a minimum right there. Then I'm going to zoom in and see if there's another turning point or no turning point. So I see only one turning point there. So we have a minimum at, oops, I should do that, -1.5-ish and -5. Do we have a maximum right there, or is it just keeps going up? And so I don't see any turning point there at all. It's just going up the whole time, so we only have one turning point. So that's our only turning point, no maximum. So I'm going to put that on our graph, -1.5, -5-ish. And that's it. So I know both ends go up. This kind of goes, kind of does that, whatever. But there's the end behavior, only one turning point. So this graph decreases. So we start, and it decreases to -1.5. And then from -1.5 to infinity, it increases. That's it. All right, last one. Classify it. This is called quintic. You should press pause and try it, but you can look at the work I'm doing too. So that's -x to the 5th plus 4 x cubed minus 2x and then plus 2. All right, over it goes. We made up from it. The last one, right? It only had one turning point. My goodness. Here we go. bunch of turning points. So that's good. So minimum down there, down here, right here is a minimum. So negative 1.5 and negative 1. Another minimum's right here, a low turning point, 0.4 and 1.4. Our max, we have a max right there, so that's negative 0.4 and 2.5 and 1.5 and 4.9. Let's put those on our graph. So negative 1.5 and negative 1, 0.4 and 1.4, negative 0.4 and 2.5, 1.5 and 4.9. 5. All right, and we know the right end goes down and the left end goes up. Kind of looks like that. So the first part of the graph decreases, so it starts and it decreases to negative 1.5. Then it increases from negative 1.5, it increases to negative 0.4. Then it decreases from negative 0.4 to 0.4. And then it increases from 0.4 to 1.5. And then the last part of the graph decreases 1.5 to infinity. End behavior, and we're done. So we know the right end goes down and the left end goes up. That's it. You did it. Mr. G Math over and out. I'm proud of you for doing your homework. Until next time.